Good evening to all. Is the video and audio clear? So let us begin our today's session. So any queries to anyone over the previous class? Any doubts with regard to basis, dimension, and how to calculate the basis and dimension for a specific problem? So do you have any on that? Say. All right. So let us begin our today's session on linear transformation. So the definition is you take two vector spaces over same field F. So in particular, U over F is a vector space and V over F is a vector space, and I am considering a function T from U to V. So you can define a function T from U to V in any manner. If T satisfies two conditions, then we say that T is a linear transformation from U to V. Those conditions are T of alpha plus beta equals to T of alpha plus T of beta for all alpha beta belongs to U, and T of A alpha equals to A into T of alpha for all scalars A belongs to F, and for all vectors alpha belongs to U. So this is the definition for linear transformation. So what is the criteria for it? You should consider two vector spaces over the same field. You can define a function T between them in any manner. If the function satisfies the two properties, then we call it as a linear transformation. Okay? Any doubts? So it is possible to define a linear transformation always, because you simply take T of alpha is equal to the zero vector. It is just like the zero function. It satisfies the two properties, so by default it is a linear transformation. So apart from this, you can have different functions which satisfies the two criteria, so we call them as linear transformations. So one good observation is, since I have taken two different spaces here, apart from this I define the function from U to U itself. It is just like F is a function from R to R. So I take a function T from U to V which satisfies the two conditions. Then it is also called a linear transformation, since domain, codomain both are same. Apart from calling it as linear transformation, we call it as linear operator. So if domain and codomain are distinct, we call it as a transformation. If domain, codomain are same, we call it as an operator. Now, the other thing is, whenever a function is given to you with some condition, if you want to check whether it is linear or not, we go for checking the two conditions. Apart from this, there is a necessary and sufficient condition that instead of verifying two conditions, we simply verify one condition, which is T of A alpha plus B beta equals to A into T of alpha plus B into T of beta. For all vectors, alpha beta belongs to U. For all scalars, A comma B belongs to F. So, with respect to the constraints of the problem, you can make use of any of the definition. Either this condition or verifying the two conditions we can make for a specific problem. Okay? So, if you consider an identity function, suppose T of alpha is defined as alpha itself, T of x equal to x. Such type of function we call it as an identity operator, where domain and codomain are same, right? So are you clear with this definition? Say. Then I am going to take some more definitions. Now, whenever we consider a function, under the function we calculate the images. In other words, we call it as range of the function. So, suppose T is a linear transformation from U of F to V of F. The range of T, nothing but all images of the domain U under the function T, we denote it as T of U or R of T. For majority of the times we use the notation R of T. And how we define it? Set of all images of U. So whenever alpha belongs to U, T of alpha belongs to R of T. This is the definition of range of T. And we go for one more definition, that is null space of T, denoted by N of T, and it is defined as set of all elements in the domain such that whose image is 0. So these are two important definitions which are useful while solving the other problems. Clear? So please take a note of them. After noting, please inform. So if you consider a small picture, suppose this is the vector space U, this is the vector space V, and T is a mapping between these two. Now what happens? Range of T is a part in the codomain. And N of T is a part in the domain. If you observe the definitions, for N of T, we are taking the vectors in the domain for which the image is a 0 vector or the 0 thing of the codomain. So for N of T, there is one more word, we call it as kernel. So one interesting thing is, these two are nothing but subspaces in the vector spaces. So N of T is a subspace for U, R of T is a subspace for V. Please understand one thing, that whenever we define a function between the two vector spaces, always 0 vector is paired with 0 vector. So this 0 bar generally indicates the 0 vector in the domain, and this 0 dash indicates the 0 value in the codomain. It may be a function, a matrix, or anything, or a vector. So always 0 value is mapped with 0 value. So if you have a small doubt how these becomes subspaces in those respective sets, let us have a small thinking. Suppose I want to prove that n of t is a subspace in the domain U. Now, since always 0 image is nothing but 0, 0 vector belongs to n of t. So n of t is a non-empty set. And also, in order to prove it is a subspace, I make use of necessary and sufficient condition. So I will take two values, alpha beta belongs to n of t, and I will take a comma b, two scalars belong to the field f. Now if I want to use the necessary and sufficient condition, I should prove that a alpha plus b beta belongs to n of t. Then I am done with my task. So the thing is, if you observe the definition of n of t, you can say that alpha belongs to n of t only when its image is 0. That is called kernel or null space. Similarly, if I am able to prove that image of a alpha plus b beta is 0 under t, then by definition a alpha plus b beta belongs to n of t. So for that I consider t of a alpha plus b beta. Since t is a linear transformation, applying the linearity property here, a into t of alpha plus b into t of beta. Basically, I considered alpha beta as elements of n of t. So from its definition, it is nothing but a into 0 dash plus b into 0 dash, hence the result is 0 dash. So a alpha plus b beta will belong to n of t, hence by necessary and sufficient condition n of t is a subspace in U. In the similar way, we prove that a alpha plus b beta will belong to R of t, where alpha beta belongs to R of t. So R of t will become a subspace of V. So this condition is very useful while proving the subspace criteria. So do you have any queries with regard to this? Null space, range, and how they will become subspaces? Please tell. If you have any queries, you can ask. Otherwise, I take the others. T of alpha image is 0 dash because see, I took alpha beta n of t. So T of alpha 0 dash, T of beta 0 dash. Right. So in a simple manner, in order to understand n of t, we should take that a value x will belong to n of t if and only if its image is 0. That's it. That is nothing but the definition of n of t. Because always 0 vector is paired with 0 vector. There is a proof for it. I will show you. But proof is immaterial. I will give the proof for you if you want it. How image of 0 will become 0. Okay. Fine. Any other questions, please? Okay. As n of t is 0, it belongs to, please understand, I will give the clarity over it. Say, the vector spaces what I considered are like that, let me say. Now, here I have paired them like this, 0 with g dash, a with 1, b with 0 dash, c with 0 dash. This is my pairing, let me suppose. So, if I want to know what is R of t, you are going to consider all images for this set. So what it is nothing but 0 dash, 1, and you have 3. Accepted? R of t is nothing but all the images. So if you want to write n of t, it is nothing but 0, b, c. Because in the domain U, you have the values a, b, c, d, e and 0. Always 0 is paired with 0, that is by default as a part of n of t, and images of b and c are 0, hence b and c will come under n of t. So while writing n of t is a part in domain. You are checking that in the domain for what values I am getting 0 outside. So for what non-zero input values I am getting 0 as output. You just think like that for the case of n of t. And R of t means you are simply considering all the possible images in the domain, for the domain in codomain. That's it. Is this clear now, the description with regard to R of t and n of t? Right. Please understand that we have a concept of invertible functions. It is simply nothing but t is a bijection. So at the school level or college level, we learned that we can calculate the inverse of a function if the function is a bijection. Right? Now, the other thing here is, here in other terms we say that if the function t is non-singular, then it is invertible. You are able to calculate the inverse of the function. So how do we say that t is invertible? By checking it is non-singular or by checking it is a bijection. The definition of non-singular is if n of t contains 0 vector only. So here n of t contains 0 and other vectors also. If n of t contains 0 only, then it is called non-singular, then it is invertible. Okay? Clear now? Because always 0 is paired with 0. Please understand. Apart from this, you are checking for what are the non-zero values whose image is becoming 0. That you are checking separately for the case of n of t. Right? Now, let us take some other definitions that, as you know that R of t and n of t are subspaces. R of t is a subspace in the codomain and n of t is a subspace in the domain. So, for every subspace, we can find the basis as well as the dimension. It is possible. So, if you are able to find a dimension for null space, that means you are able to determine a basis for the null space, the set of vectors, and you are able to count how many elements are in that basis, nothing but dimension. The dimension of n of t, we call it as nullity of t. Symbolically, we denote with mu of t. Similarly, for R of t, if you are able to find its dimension, that means you are able to deduce a basis for R of t, and you can find how many elements are there in that basis, which is nothing but dimension. So we call it as rank of the transformation, denoted with the symbol rho of t. So these two are interesting definitions. So based on these definitions, one good theorem is framed. We call it as rank nullity theorem. It states that suppose you have a linear transformation from U to V and the domain is finite dimensional, then dimension of U is equal to rank of the transformation plus nullity of the transformation. This is very useful theorem. Based on this, so many problems are asked under UPSC. Okay. So please take a note of it. Then let us do some problems which will give you an idea. After noting, please inform. Any doubts over these definitions to anyone? Fine. Now let me say, suppose T is a linear transformation from R cube to R square. So what does it mean? Transformation means it is changing from one priority to the other priority, or conversion we can call it as. So if I use that T of xyz is equal to this is my transformation. So you can observe that the input is a 3D vector, the output is a 2D vector. So you are converting 3-dimensional into 2-dimensional. So the applicability of linear transformation is rotation, dilation, stretching the vectors, etc., etc. So it has many uses and applications under 2D and 3D graphics. Suppose if you want to rotate a surface, a homogeneous surface or non-homogeneous surface, in such situations we are going to make use of these transformations. Fine. Now this is my problem. I took the function t from v3 of r to v1 of r as t of abc is equal to a square plus b square plus c square. Now my question is T a linear transformation or not? So here you can make use of the two conditions or one single condition is there. Whatever the thing it is, you can make use of that property to verify the checkingness, to check whether it is a linear transformation or not. So if you observe that t is a function from v3 to v1, nothing but you are converting a three-dimensional thing into a one-dimensional thing. So let us do the part that say alpha is equal to a, b, c or a1, b1, c1 and beta is equal to a2, b2, c2. Take them in the domain. Now I am going to make use of the first condition. Suppose I am considering t of alpha plus beta. So t of what is alpha plus beta? If you add it, it is a1 plus a2, b1 plus b2, c1 plus c2. So what is the condition of t? Whenever you take a 3D vector, you are taking sum of the squares of the coordinates. Applying the property here, it is a1 plus a2 whole square plus b1 plus b2 whole square plus c1 plus c2 whole square. So did you get that? How the function is defined and how we are going to apply t condition here for the input. Now what is the first condition for linear transformation? T of alpha plus beta is equal to T of alpha plus T of beta. Now let us do the RHS. Let us sum T of alpha plus T of beta. So if you take RHS, T of alpha means, using the definition of mapping T, a1 square plus b1 square plus c1 square plus T of beta is nothing but a2 square plus b2 square plus c2 square. So this is LHS value and this is RHS value. Are they equal? So is T a linear transformation? No. So this is the way we check for the linearity property of T. You can make use of a single condition or the two conditions you can make use. No doubt at all. If one condition is failed, it is enough to say that the function is not linear. That's all. So do you require any other problem or that how to check the linearity property? Anyone? So we calculate LHS, RHS separately and we check whether they are equal or not. That's all. If they are equal, it is linear. If they are not equal, it is not linear. That's all. So please take a note of that. Now, how to define a linear transformation from the given input? Let us discuss with this case. So, what is the criteria for defining a transformation? Suppose I have taken two vector spaces U and V. Now in U I considered the set X, Y, Z which is a basis of U. In V I considered a set of values A, B, C. So this is a basis. In V, A, B, C are not basis. So I can define a mapping T between these two such that one value is paired with one value there. So pairing is user defined. You can do any manner. So I am going to take it as T of x is equal to A, T of y is equal to B, T of z is equal to C. So in order to consider or define a transformation, if we are taking that one value is the image for one value in the domain, the value what you are taking in the domain must be a vector in the basis or an element in the basis. That is the checking condition to define the transformation. So the transformation changes the basis values from one thing to the other thing in codomain. That's all. Did you get the logic there? What I stated? So what I am saying, let me say if U is a vector space having vectors alpha 1, alpha 2, so on alpha n, I am saying that these values are basis of U. Now, how many values I considered here? N values in U. So, what is dimension of U? N. Now, if you take V, you can take any values in V. V may be bigger or smaller, whatever it is. So, since here I considered N distinct values, you should consider N distinct values in V also. Please understand that betas may basis or may not be basis. They are just n vectors in the vector space V. So I am synchronizing these values under the mapping T. How? One alpha is paired with one beta. That can be done in any manner. So I am taking it as T of alpha is equal to beta I. So T of alpha 1 equal to beta 1. T of alpha 2 is equal to beta 2 and so on. T of alpha n is equal to beta n. V may contain so many values, but the mapping is defined in such a manner. Okay? Is the perception clear to all? Right. Now let us do one small problem which gives good idea what I have stated now. So this is my problem. So describe explicitly the linear transformation T from R square to R square defined by or such that T of 2 3 is equal to 4 5, T of 1 0 is equal to 0 0. So what does it mean? I considered domain and codomain as R square and R square. In the domain, I considered two vectors. One vector is 2 3, other vector is 1 0. And I am saying that I want to define a function t from R square to R square, which is a linear transformation such that it transforms the vector 2, 3 as 4, 5 and the vector 1, 0 as 0, 0. So is it possible to write a condition that T of xy is equal to something such that if I apply the condition for it, 2, 3 should be transformed as 4, 5, 1, 0 should be transformed as 0, 0. So if you feel that 2, 3 is a vector in the two-dimensional space, so you can do any kind of thing, rotation, stretching, anything you can call. So the vector 2, 3 is changed as 4, 5. The ray is changed as 4, 5. And 1, 0 is shifted to origin, like that. Clear now the objective? Right. Now what happens for the linearity transformation? The main thing we need to take is the domain thinks what we have considered must be a basis. In codomain, 4, 5, 0, 0 must be anything. We don't bother about the images. We bother about the elements in the domain. Are we taking basis elements or different elements for the description of a transformation? So for that, I want to check the set 2, 3 and 1, 0. Is it a basis or not? T of 0, 0 is always 0, 0. That is by default. There is no need to define it separately. For every 0 vector, if you apply T, you get the result as 0. That's it. Suppose you are defining the mapping as r square to r cube. Then T of 0, 0 equals to 0, 0, 0. So two-dimensional 0 vector is converted into three-dimensional 0 vector. So image of 0 is always 0 by default. There is no need to do it separately. So I am taking that 2, 3 will be changed as 4, 5, 1, 0 will be changed as 0, 0. Is it possible to define such transformation? Fine. Now is that clear to all? Right. So can you say that is this set linearly independent or not? You can simply calculate the det becomes not equal to 0. So it is linearly independent. Accepted? Yes or no? Do you agree for it? It is linearly independent? Or you can write the linear combination as a into 2 comma 3 plus b into 1 comma 0 is equal to 0, 0. So that 2a plus b comma 3a is equal to 0, 0. From this, it is evident that comparing the coordinates, solving the equations, a is equal to 0 and b is equal to 0. So in the linear combination, the scalars a and b has become completely 0. So it is linearly independent. The shortcut technique is for 2, 3, 1, 0, write it as a matrix, calculate det. Since det is not equal to 0, it is linearly independent. That is shortcut. The other thing is I want to check whether this set spans R square or not. So what does it mean? If I take any vector xy in R square, then am I able to write xy is equal to some number into 2 comma 3 plus some number into 1 comma 0. That means every vector in R square can be written as a linear combination of the two vectors. If it is done, then it is nothing but a spanning set for R square. So obviously let us take that P and Q are the scalars. Now if I find an expression for P and Q, the scalars, in terms of xy, then I can find a linear combination. It is nothing but the spanning. So xy is equals to Now, can you give the value of Q here? So 3x minus 2y by 3. Right. So what is my unique expression? Whenever I take xy, the linear combination is y by 3 into 2 comma 3 plus 3x minus 2y by 3 into 1 comma 0. So for every xy in R square, I found a linear combination of it with respect to the vectors 2, 3 and 1, 0, where the scalars are obtained by using the unique expression y by 3 and 3x minus 2y by 3. Hence, the whole R square is spanned by the two vectors 2, 3 and 1, 0. So earlier we proved that it is linearly independent there, and here you proved that spanning is possible. Hence, these two vectors together constitute a basis for R square, the domain. Okay? Any doubts? Okay. Then our main aim is what is the condition of T so that it transforms this vector as that vector. Now let us do our part now. Because is it possible to have a transformation or not? For that we are checking whether the given set of vectors are basis or not. You have done that, it is a basis. Now you are defining a transformation. Please understand, the condition of transformation is T of A alpha plus B beta is equal to A into T of alpha plus B into T of beta. This is the linear property. So by assuming this condition, I deduce a relation for T. So this is the equation I got. X comma y is equal to some number into 2 comma 3 plus some number into 1 comma 0. So for this expression, apply T on both sides. So you have T of xy is equal to T of y by 3 into 2 comma 3 plus 3x minus 2y by 3 into 1 comma 0. So please understand that on the right side, it is of the form T of A alpha plus B beta. Since T is linear, applying the T condition here, y by 3 into T of 2 comma 3 plus 3x minus 2y by 3 into T of 1 comma 0. Now please understand that our required T should transform the vectors like this. So from the given images under the problem, I write it as y by 3 into 4 comma 5 plus 3x minus 2y by 3 into 0 comma 0. From this, the condition of the transformation is nothing but 4y by 3 comma 5y by 3. So this is the way in defining or deducting the transformation from the given set of images. This tactics is applicable to two-dimensional, three-dimensional, n-dimensional, matrices, polynomials, everything. On the total, if you recap what we did, we have considered the domain vectors or domain elements what are given to us. For those domain elements, we checked are they linearly independent or not. That is step 1. Step 2, we obtained a linear combination here because it is a spanning set. And third, for this expression, we applied T on both sides and substituted the required T images we want actually, then we got the condition of T. That's it. Any doubts to anyone? Say, is the objective clear to all? Now let us take one good problem on this rank nullity theorem that will be very interesting and important also for UPSC point of view. So the problem is, T from V4 of R to V3 of R is defined by T of ABCD equals to verify rank nullity theorem. ORR, you can call it as find rank of T, nullity of T, find the respective bases, etc., etc. Whatever the question tag is, our objective is verifying rank nullity theorem. Okay. Is that clear to all? Now let us do it. So you are going to find R of T and its basis, and you are going to find N of T and its basis. If you know what is the respective basis for those sets, then you are able to determine its dimension, because those dimensions are nothing but one value is rank and one value is nullity of T, and we check for rank nullity theorem. This is the whole strategy. Is it clear? Any questions? Please tell. Do you have any? All right. Now R of T is nothing but the image set. That means you should know what are the values in V3 under the function T, the images. Please understand, if you take some value here, by applying T, you will get the corresponding image here. So what values we should take here in order to get R of T? As you know, the criteria for transformation is based on basis. So for the domain V4, let us take the basis. As I mentioned, for every vector space, we have the standard basis. V4 means the dimension of the domain is nothing but 4, where each value contains 4 coordinates. So what is the standard basis? The vectors taken by the combination of ones and zeros. So 1, 0, 0, 0 is one vector, 0, 1, 0, 0 is the other vector, 0, 0, 1, 0 third vector, and 0, 0, 0, 1 fourth vector. Clear now? So this is the standard basis for T, for V4, the domain. Now for this, I am applying the condition T, because for every value here, if I apply T, I will get an image here. So say this is as A, B, C, D. So T of A, B, C, D, if you apply, can you give me the image value there? I will say you are going to get it as 1, 1, 1. Could you check on that? Please check with me. Accepted all? Now see, this is a basis. If you apply T for the basis, the result usually a spanning set, not a basis. So this set is a generating for the range. In other words, you have obtained a set of vectors in R of T. So using them, I am going to get a linearly independent set, so which gives the basis as well as I can calculate the dimension. So you consider them as a matrix. Now apply row operations and reduce that into echelon form. I can say you can apply the row operations very easily. It is possible for you. So I will simply write the output. You can check with that. Please check that. I think you are able to apply the row operations. Are you? Or you want me to apply them? So take a minute of time and please solve. Are you able to get similar matrix like me? I will wait for you. So once you get the matrix, please notify me. So from the very definition of T, you can observe that you are transforming a 4D vector into 3D vector. From the images, it is evident. Did you observe? Right. So if everyone confirms that that is the matrix we got, see, from the non-zero rows, the vectors are 1, 1, 1 and the other vector is 0, 1, 2. So from this we say that this is the basis for R of T. Since it contains two vectors, dimension of R of T is nothing but 2. Hence, rank T is nothing but 2. Okay? Please take a note of it. Now, let us go with the second part. As I got a basis for R of T, in the similar way I should get a basis for N of T, so that I can find what is the nullity of the transformation. So if you write the definition of N of T, Accepted all? The n of t definition? Yes or no? Any questions? So, what is alpha here? Any vector in the domain for which its image should be 0. Those things you are taking under n of t. So n of t gives that you are counting what are the vectors in the domain set whose image is becoming 0. So I will take alpha as a 4D vector in V4 such that t of alpha is equal to 0 dash. Here 0 dash means the 0 vector in the codomain. So here you have t of a, b, c, d is equal to 0, 0, 0. Because codomain is a 3-dimensional thing, the 0 vector is nothing but 3 zeros. So if you apply the condition a minus b plus c plus d, a plus 2c minus d, a plus b plus 3c minus 3d equal to 0, 0, 0. Now see, by comparing the respective coordinates, you will get a homogeneous system again. Now you are going to solve the homogeneous system. The solution space is nothing but n of t. If you find a basis for the solution space, it is nothing but basis for n of t, hence you can get the nullity, the dimension. Now how to get that? So you consider the matrix as it is, apply the row operations. Let us do for solving the homogeneous system as it is. So I will go with the usual pattern of solving the homogeneous system. This is the way to solve. Can you recollect the method? Please tell. Number of solutions is equal to number of variables minus rank. So you will have two solutions. Hence we need to take two constants. So since it is a upper triangular matrix, we usually take that last two variables as constants. So take C is equal to K1 a constant and D is equal to K2 a constant. All of you can recollect that? Fine. So since you know how to solve the equations, I am skipping that part. Is it necessary for you? How to get the solution from the constants taken? From the last matrix? Right. So if you solve them, the solution of the system is simply so minus 2, minus 1, 1, 0 is one vector, 1, 2, 0, 1 is the other vector. So I will say k1 into this vector plus k2 into this vector will come. So this is the basis for n of t. In other words, you have computed a basis for solution space for n of t. So if you apply the rank nullity theorem, the statement gives that dimension of domain is equals to so you have dimension of the domain is nothing but 4 because the function is different from v4 to v3. Domain is v4, its dimension is 4, and you observe that rank of the transformation is 2 and nullity of the transformation is 2 because there you got a 2 vector basis, here you got a 2 vector basis, hence the rank nullity theorem is satisfied. Any queries to anyone, please? Please tell. Are you clear how to solve such kind of problems with regard to rank and nullity theorem? If you have any doubts, you can ask. So can I take the other topic now? Fine. Now let us have a small problem that please note down that problem. Now here we got a transformation from r cube to r cube defined with the property that t of xyz is equal to 2x, 4x minus y and 2x plus 3y minus z. Here you need to compute two things. Usually one will be given to you in exam. One is you need to show t is invertible. That means you are able to say the function is invertible. Inverse will exist for it. And if it is so, you need to calculate what is the inverse mapping, what it is t inverse. It is just like if you have a function f which is a bijection, then find f inverse, the inverse function, just like that. Now for proving that t is invertible, we should say t is non-singular, because as in matrix algebra, for non-singular matrices you will get inverse. So non-singular function is nothing but if you calculate its null space, it contains 0 only. So let us say that alpha is equal to xyz belongs to null space of T. Say here I am taking alpha is any vector in the null space. So which gives that T of alpha is equal to 0 dash. the 0 vector. So applying that, T of x, y, z is equal to 0, 0, 0. Because domain is 3D vector, codomain is also a 3D vector. So applying the condition 2x, 4x minus y, 2x plus 3y minus z is equals to 0, 0, 0. Now if you equate the things, 2x equal to 0, 4x minus y equal to 0, and 2x plus 3y minus z equal to 0. So from the first equation, we say that x is 0. If you substitute x here, you can say y is 0. Substituting x and y 0 here, z is 0. So if you take any 3D vector x, y, z in the null space, it is becoming 0. So it is true for every alpha which you take in n of t, because I didn't take any specific coordinates for alpha. I have chosen alpha very randomly. So for every vector in n of t, I am getting it is becoming 0 vector. So n of t contains 0 vector only. Therefore, T is a non-singular transformation, hence it is invertible. Any questions to anyone so far, please? Do you have any? Please tell. Yes or no? So can I take the other part of the problem? Fine. Now how to find the inverse function? It's very simple. Let me say t is a function from r cube to r cube here. Now what happened? If I take x, y, z in r cube, if I apply t to this element, I will get an image there. So what is meant by inverse image? It comes like so. So it means that T inverse of ABC is nothing but XYZ. You accepted? So if you simply write that if T of alpha is equal to beta, agreed? The inverse function definition. I think this we have studied at a school level. How do we define F inverse, right? Am I correct? If you cannot recollect that, you please take a note of this definition. Fine. Now let us do the part using the definition. Say T of XYZ is equals to ABC. Substitute the values 2x, 4x minus y, 2x plus 3y minus z equals to ABC. So if you equate them, 2x is equal to a implies x equals to a by 2. Right. Now You have 4x minus y is equal to b, implies 4 into a by 2 minus y is equal to b, implies you get that y is equal to 2a minus b. I can say that similarly, comparing the third coordinate also, you will get that the value of z as 7a minus 3b minus c. Clear to you all? You can verify that on your own. Now I am going to write the inverse function. How I am writing? Simply check that. T inverse of ABC is equal to xyz. So this is equal to x is nothing but a by 2, y is nothing but 2a minus b, z is nothing but 7a minus 3b minus c. So this is the inverse function definition. So T inverse of ABC is equal to a by 2, 2a minus b, 7a minus 3b minus c. So in this model we calculate the inverse function. Please tell if you have any doubts. Clear to you all? Right? So please understand that if you are dealing with linear transformations, don't feel them separately. They are just functions. As you have done so many problems at school level and calculus level with regard to the functions, the same things will be obeyed by t also here. Very simple. Suppose if I have given t plus h, where t is a transformation, h is a transformation. So t plus h of x is nothing but t of x plus h of x. As we do, f plus g of x is equal to f of x plus g of x. If I have mentioned t square of x, it is nothing but t of x. It is just like t circle t, like that. If I have given t square, you are applying t inverse 2 times. That's it. So whatever the part we do with regard to functions, just like 4t minus 5h, 5t plus 6, etc., etc., all these are nothing but the functions properties what we do actually earlier. Nothing different is there. Okay. So at this point, I want to conclude my discussion. So in tomorrow's class, I want to take about matrix of a linear transformation, which is very important with regard to UPSC point of view. So we discuss that in tomorrow's session. So if you have any other queries with regard to today's session, you can ask. Otherwise, let us wind up our session here. Thanks for your good listening. Suppose if you are taking with the product th of x, it is just like t of h of x. Just applying composition of the mappings. Nothing difference is there. Okay. Any other queries please from anyone? Or let us close now.